Now we're going to turn our attention to the card table and learn to calculate some basic probabilities. It's super important that we know how to do these before moving on to more advanced stuff like poker hands, so let's get really good with the basics. Before jumping in, a quick reminder on the definition of probability. To calculate overall probability, we ask ourselves two questions. First, we ask how many total possible outcomes are there. Next, we ask how many successful outcomes are there. After determining these two numbers, we can calculate probability, which is defined as successful outcomes divided by number of total possible outcomes. Seems simple enough, but this definition is actually super important because we're going to be using it to solve every probability problem. So we'll leave this formula right here in the bottom left, and now let's get into today's problem. So it's just one problem, but there are four parts to it. We have a randomly shuffled deck of cards. We're going to calculate the probability that the top card is a heart, like this 3 of hearts here, or even an 8, like this 8 of clubs. Also drawing the jack of spades, and finally drawing a face card like this king of hearts. Let's begin. So first, let's calculate the probability that the top card drawn is a heart. We start by calculating the total number of possibilities. How many possible options do we have for the first card? Well, the first card drawn could be any of the 52 possible cards in the deck, so there are 52 possibilities. And guess what? We're already halfway there. Nice. Next, a successful outcome is defined as drawing a heart. So how many hearts are there? Well, we can list them out nicely. They are the ace of hearts, 2 of hearts, 3 of hearts, so on and so forth, all the way up to the jack of hearts, the queen of hearts, king of hearts. So there are 13 of them. This means the overall probability is successful outcomes divided by possible outcomes, which would be 13 over 52, which simplifies down to 1 over 4. So always remember to simplify your fractions as much as possible when it comes to probability. Next, calculating the probability that the top card is an 8. So this time, instead of a specific suit, we're focusing on drawing a specific number. Again, first we ask ourselves, total number of possible outcomes. Like last time, there are still 52 possible cards to choose from, so that number remains unchanged. But what about successes? Well, this time there are only 4 possible 8s, the 8 of clubs, 8 of diamonds, 8 of hearts, and 8 of spades. This means the overall probability is successful outcomes divided by possible outcomes, which would be 4 over 52, and that simplifies to 1 over 13. Case number 3 would be drawing a card of a specific number and suit, so this is as specific as it gets. There are still 52 possible cards to choose from, so you can see this number isn't really changing for now, and there's only one successful outcome, the jack of spades. There is no other jack of spades in this deck unless there is some card magic going on that we are unaware of, so the probability is 1 over 52. Nothing to reduce here, nice and simple. Finally, calculating the probability that the top card is a face card. For those who don't know, the definition of a face card is a jack, queen, or king. Anyways, as usual, we start by asking ourselves the total number of possible outcomes. That's still 52. As for successful outcomes, let's lay them all out. Now if we do that, we can see we have 4 jacks, 4 queens, and 4 kings, so that's 12 cards. This means the total probability is 12 over 52, which reduces to a final probability of 3 over 13. So that was a little bit of practice for calculating simple probabilities. But you may have noticed in this video the number of successes changed while the total number of possible outcomes was always 52. But this will not always be the case. What happens if this number changes? And how can this be possible? Think about those questions since they will be answered in the next video. Bye.